UML diagram. Finally, we'll simulate the problem and refactor it using the concept we learned using the factory pattern and make our code clean. At the end, we'll be looking at the disadvantages and advantages of this pattern and an overview on how to identify when to use this pattern. At the end of each section, we'll be comparing all the patterns which come in the same section and discuss the combined usage. So, let's get started. Now, by definition, it's a creational design pattern that provides an interface which encapsulates object creation and lets the subclasses decide what objects to create. Now, to actually understand the essence of this pattern, you need to actually understand the problem which lies within the object creation. And to make you understand, I have created a very small example which will demonstrate the problem. So let's have a look at it. Well, here's our example. In this example, we are trying to model a pet store. This pet store only sells two kinds of animals. They are a dog or a cat. So we have a base class called animal, which these two classes will be extending and providing their separate behavior. This base class animal has a name and two different behaviors: make sound and move around. The cat class extends the animal class and provides its own implementation of those behavior, and similarly the dog class does the same. So let's go to our pet store class and try to figure out what's the problem. So now we are back to our pet store class. So in this class, this main method is the main client for this pet store. This main method is trying to instantiate a pet store object and trying to call a order pet method on it with parameter dog. So this order pet method decides based on the parameter which kind of animal class, animal subclass it needs to return. So if it's a dog, it will return a dog animal subclass. If it's a cat, it will return a cat animal subclass. And the problem is that this is the creational logic we are talking about. So according to single responsibility principle, every method should have only one responsibility. Now if you take a look at order pet, this method has two responsibilities. The first one is the creation of the pet, and the second one is ordering the pet. Along with the single responsibility principle, we are also violating the open-closed principle. Open-closed principle says that your classes should be open for extension and closed for modification. Now let's imagine a scenario where you want to add 4 more pets to it. Now, to add 4 more pets to your pet store, you need to add 4 more else if ladders here. So to add behaviors to your pet store class, you need to change your pet store class code. So your class is not closed for modification. Also, it's not open for extension because your code is tightly coupled to the creational logic. We cannot inject something and don't care about the implementation of the creation and get the subclass return and perform operation on it. Third thing is, suppose this piece of creational code is spread across your code base at 100 different places. Now can you imagine the maintainability problem for this kind of code? Like your creational code is spread across, this code repetition is being done. So we need to encapsulate this creational logic into a separate class, and that class will be called a factory class. Now, as I have said, I've created one animal factory class which has a static create animal method, and I have replaced all the creational logic which was there in this order pet method and kept it in this factory method. So now this factory method will take a pet type and create a animal subclass instance and return. So now this pet store is free of creation. So this order pet is no more creating a animal. It's just delegating the responsibility of creation of animal to the factory. And as I have said, if there are more than one instances of the same creational logic repeated across the code base, all those instances could actually use the same factory to create the animal and get the actual subclass instance in return. This way of implementing the factory pattern is called the simple factory method. In this method, we have a factory which has a static method called create animal, and it is creating the desired animal for us. In this video, we learn how to encapsulate creational logic using a simple factory method pattern. In the next video, I'll be going further and removing this concrete dependency of animal factory from the pet store class and actually making it depend on an abstraction of the factory and then extending that factory and then providing the behavior by inverting the dependency. So even here, even if that pet store does not have that responsibility of creation of the animal, pet store still knows and has access to the creation of the animal. It is not depending on an abstraction for it. So in the next video, we'll go ahead and make this change and create a pet store without a dependency on a concrete animal factory. We'll also take a look at the UML diagram and discuss the advantages and disadvantages of this pattern. If you have any queries, suggestions or doubts, feel free to ask it in the comments and I'll try to answer it. And yeah, thanks for watching my video and I'll see you in the next one.